roll the intro.
All right. Good morning, everyone. I'm Brian Walsh, co-founder of Exerceo. Here with me today is Julio Valcarcel. So we'll talk a little bit about Exerceo first. So Exerceo exists to lead and inspire others to transform society by extending relevant learning and mentorship into the everyday lifestyle. How does this translate to everybody? Well, really what our goal is to help professionals successfully enter the workforce and rise within the workforce. And so that's what ultimately the working groups do this morning. And then we have additional resources. We have a Rising Professional Challenge series. I really am passionate about that and helping professionals participate in that their first year. In addition to that, we have a Rising Leaders Challenge series. What you'll find is even if you're not formally taking a leadership role, a lot of times you'll informally be leading, hopefully. And so following the Rising Leaders Challenge series is another way to help gain some of those skills and help prepare you for that. So as always, Pat is not joining us this morning, but in his honor, he would love it if we could help with likes and shares on social media. He's been working really hard to help get the word out across social media. So I can't thank him enough, and letting him sleep in is a little bit of a thank you this morning. All right, so today's content, we're going to jump right into it. We're going to go into talking about build tools. We'll go over build tools, testing, and then we'll conclude today with a 5-year roadmap for software developers. All right. Oh, logistically, Julio will post the attendance.
Yes, I'm doing that momentarily.
All right, so please sign in. We'll use the attendance to, once we sign you in and save that in the attendance, it automatically sends out all the notes from today in a PDF format. So you'll have at least a copy of what we're talking about today to reference if you don't want to see us in our mugs in a video again and listen to us again. So, all right, so we'll jump into build tools. So why are build tools important? Well, if you watched the first episode, you heard us talk about automation. I might be a little bit passionate, or you could call me crazy about automation. It's because I'm lazy. I don't want to do the same thing twice. I want to get more done in a little time. And what build tools allow us to do is automate things. Ultimately, the other thing it does is, last week we talked about revision control. Really good build tools usually put their build processes in some sort of text document that we can check into our revision control system. And that allows us to share it amongst the team, create a standard. Again, laziness, right? We don't want to have everybody maintaining their own build for the software, because then everybody's trying to do things separately and make changes, and it's just a lot of extra work. So if we can check that in and it's some sort of text document, then we can share that document, and then all of a sudden we can automate that document with scripts. Since it's checked in, it's just a text document. If you look at Maven's one of the great examples lately. You can basically automate all your Maven things on the command line. And so I'm really passionate about making sure that we do those things. Gradle is another build tool that has more flexibility and allows some more customization. So what we have found is if Maven doesn't do it, we kind of revert to Gradle from a technology.
We've actually started, I'll say on one of our projects, starting to use Gradle more so for larger efforts. Maven's really easy to get up and running really quickly. It's a great first place to start, and will scale pretty far with your application on the Java side of things. Gradle goes and takes that to the next level when you have to do more complicated things that you might not be able to do with
and
Maven.
They integrate together, right?
One's a replacement. Well, there's
I thought
compatibility.
It
uses
your
yes.
old, uses a lot of your Maven stuff. From the
somewhat.
past.
There's some massaging that has to be done.
Okay. Not quite magic.
It's not just magic now. And then there's plenty of other build tools. Obviously, we're a little biased to Java side of things. On JavaScript, you have things like a combination of NPM or Yarn plus something like Webpack, or if you're doing React, create React app. And most frameworks on the JavaScript side have their own set of build tools around Webpack. And then a lot of languages have these build tools for you. It's about using them, about having them in place.
C# has switched to those over the last couple of years. It's been nice. Well, let's step back real quick and talk about history of build tools a little bit. I think that helps people understand the relevance of things. And so Make was kind of the original cross-platform build tool. It started with the C++ days, and actually a lot of Linux users will still see references to make around. And so make, the one thing that I didn't like about make was it was a tab delimited build file. And I don't know about you guys, but I have a hard time telling tab from spaces.
I struggle with that with the YAML files nowadays. The YAML files are like the new favorite thing, and they're tab delimited or space delimited.
Yeah, I hate anything that uses spaces or tabs. And the old famous thing in the make file was a knucklehead like me would get in there and hit a space to align something, and that would just break everything. And so I always struggled because of my need for things to be neat. Would use spaces, and it was not friendly. So it was hard to debug those kind of problems. And so kind of along came Ant, which was kind of an Apache project that was XML formatted. And so it got rid of the white space. For those of you that are aware of XML, is not a white space-based language. So that was really nice. But one thing that we found with Ant was missing was the dependency management. And so what a lot of projects did back in the day is they all had this lib folder, and you would dump all your libraries in the lib folder, and you'd have a lib/star in your Ant project. So you'd pull in anything in the lib folder. Well, I'll be honest with you, it created kind of bad habits because people wouldn't pay attention to the versions of the libraries, or you'd have multiple versions in the lib folder, and it just became like a dumpster. People would just throw things in, nobody would ever clean it out, right? And eventually, it's just like the trash can at home. It's overflowing. Nobody wants to clean it up. And what Maven did is they added the dependency management, and so that really helped starting to clean things up. And so that really introduced that process, and that was a big improvement. And the other thing that Maven did that I, again, very passionate about was convention over configuration. Is Ant gave you flexibility. You could choose your conventions, but the problem was then you had to code it all into your Ant scripts. So, I had something like 10 pages of Ant scripts for my builds back in the day. When we went to Maven, convention over configuration, all we did is change the file structures to follow their convention, and then they just knew where to find things. And so Maven test, Maven compile, all that stuff worked without having any setup. And so that was really nice. So it simplified our lives. Again, kind of lazy, automate, go to that. And so all that's important to understand the evolution of where we came from, why it's important to move forward and get to these future platforms like Gradle. Gradle supports a lot of the convention over configuration.
It does a little bit. It's definitely convention over configuration, but then heavy configuration. You can start essentially programming in Groovy in it. So it starts to give you back some of that flexibility you need nowadays with continuous integration.
To do more of the advanced features.
Yeah.
Yeah, I remember we looked at that early on, probably 5 years ago, and started trying to use it.
It's actually the default for Android now.
Is it?
Yep. So Android now uses Gradle by default. So if anybody's on an Android app, you've used Gradle, whether you knew it or not.
Yeah. So back to Maven, they introduced the concept of the artifacts, so the group ID, artifact ID, and version in the POM files. And so that allowed us to all of a sudden start doing our automatic dependency mapping. And that was really nice because now I can say, oh, hey, if I pull this dependency in, back in the day with Ant, you'd have to go, hit compile. This is the way I did it, and see what library was missing, and then you'd go find that one, you'd add it to your lib folder, hit compile again, and you'd go through that process multiple times until you had all 50 of these libraries. It was kind of back to the old Linux RPM kind of concept, right, where you'd install one and say you depended on another, and you'd have to go find these dependencies. Whereas now, with the dependency management, it'll pull them all in automatically for you. And then when you change the version, it'll update those, and it'll kind of manage everything automatically behind the scenes. And so it really takes a workload off of the developers now going forward. So that's nice. So the other thing with build tools, we want to make sure you don't confuse your IDE. Let's just say, I don't know, pick NetBeans or
IntelliJ or Eclipse, or
any of those.
Or Visual Studio. Well, Visual Studio Code's more of an editor, but any of these tools where they have a button that says compile. Go build or compile,
F5.
Yes, it's important to understand the difference between build tools and having a uniform team-based build tool versus your IDE. In that most cases, I know Eclipse is famous for this, and I think even NetBeans, and I'm not sure about IntelliJ, but I'm sure they do, have their own set of build tools that that you can go and set up a project in. So you could have your project build as an Eclipse project. The difficulty with that is now you're tied to your IDE, so your entire team needs to use that in order to build it. More than likely, their command line configuration or ability to run the build on the command line without a GUI is limited or not super supported, or if it is, there are significant limitations. Whereas any of the build tools we've mentioned before, or just an agnostic build tool, allows you to go and really have a robust command line way to interact with your build so that you can go and start automating it. You can write scripts. You can go and put it onto a continuous integration server, so something like Jenkins, or there's plenty of others out there, TeamCity, and anything that goes and automatically runs your build. It's a cron job that just runs it. That also means that anybody on your team can go and build it with whatever tool that they want to go and use for their editor. They don't have to go and use Eclipse or IntelliJ. So typically we see this as when you go and you create a new project. If you go open it up and then you say, open up Eclipse and click create new project and create it as an Eclipse project. Well, now your build's tied to Eclipse. Instead, you want to go and say, hey, I want to create a Maven project or a Gradle project, or I think in C++ they now have CMake, which is like a more complicated make, or AutoMake. There's a whole bunch of different tools out there, but separating those two things apart are important to having a cohesive project that others can contribute to.
Well, I know I'm not going to be everybody's favorite person when I say this morning, but I'm really not a big fan of forcing all of the developers to use the same IDE, right? I love providing freedom, right? If one developer wants to use their specific IDE, allow them to do it, right? I really get frustrated when I see all these job ads out there that like, oh, you have to know Eclipse, and that means, pick the favorite IDE, and then you interview and they're asking you about the IDE. It's because nobody can do the builds, and they're not doing it via a build tool. It's done through the project, and then they have somebody that's helping manage them. And I believe, and this is just me, and I know it's not a popular belief, but I believe we should use build tools and then allow the developers to use the IDEs or editors. I don't care if somebody is using Notepad on Windows and that's their favorite platform, have at it, right? I don't care what the tool is, as long as you're effective and efficient and you enjoy it, go for it. Let my developers do what they want to do. And so I know a lot of teams don't like that. They want everybody to be uniform and conform to it. I just flat out disagree. Give people the freedom to be successful.
I think that's, well,
I know it's not a popular belief.
Well, actually, no, I think it is. It's definitely a more popular belief amongst developers. And I know the ecosystem, the culture you're coming from, and I can see where management wants to go and standardize on those things, or project managers who don't understand the technical. From a developer perspective nowadays, I think that's certainly a popular belief, actually, and that might be the source of contention. Is that, and understandably so, is if you're going to use something different than the rest of your team, you better know how to use it.
You're responsible for it.
Yes.
The funny part is my whole team back in the day used Eclipse, and I was responsible for managing Eclipse, but I didn't use Eclipse on the team. Right? I was the only developer on the team. I used Emacs back in the day because I wanted it to load fast. Eclipse was too slow to load, but that's a personal thing, right?
Yeah, this is one of the reasons why we really heavily encourage junior engineers, junior software developers to not use an IDE and to use either just a text editor or just the command line with the command line build tools, so you understand what it is you're doing with the IDE. The IDE should be a tool to automate your workflow, not a crutch to lean on to do your job for you. So you just have a button to click.
I used to get so mad in interviews when they would talk about doing things in the IDE with drag and drop.
Oh yeah, that's still a thing for like mobile apps and desktop apps that you can do that, and I don't get it.
Yeah.
Then again, I haven't tried to do it, and I think there is some merit to some UI things in it, but I think as a general rule, if you don't understand what's going on underneath, you shouldn't just rely on it.
As long as you understand what's going on behind the scenes, I'm good with it.
Yep.
It's when you don't understand what's going on behind the scenes. Because a lot of times, it was great to get, the first 80% of the software written that way. But then the last 20%, we would have to go under the covers and fix things. And those that didn't know how to do it never get there. So that was my complaint there. So anyway, I think it's important to understand the concept of build tools, making sure that you are using a build tool that you can check into revision control, right? And the whole team can use that so that they can keep up to date. And it gets to the point where, if we're using a standard revision control, standard build tool, all I have to do is get my access, download the project, and then I should just know how it compiles. I shouldn't have to go pull Julio aside and ask him, hey, I can't figure out how to build this project, right? It should just be simple, straightforward. And so that's one of the benefits of using build tools. And it doesn't depend on the IDE. Download your favorite IDE, download the build environment, and then just go for it. Did we miss anything in build tools?
I don't think so.
Oh, and if anybody has questions, feel free to pop them in there. You know what? I did open the link last week, and it was extremely helpful.
Oh, to have the chat open?
Yeah, I could see it on my computer here.
Oh, that is a good idea, Brian. Who would have thought?
Yes, these obvious things.
No, I don't think. I think from a standpoint of build tools, understanding what's going on underneath is the core of it. Having something that is universal and independent of your IDE that you can run on the command line, that you can automate are the key points there. And that nowadays you don't really, again, unless you're doing something with an older tool or on an older project, you're not going to start a new project with Make. There are better tools out there. That problem has been solved for dependency management and things of that nature. So it's just identifying for whatever language, for whatever tool you're building, using the right set of build scripts and build tools to go and do that.
Sweet. All right, should we move over to testing?
I think so. This is the best part here.
We test code?
I don't write tests.
Apparently I do. All right, so there is a good Wikipedia article out there. They don't sponsor us, but they have a software testing article. It's in the notes here. It goes through a ton of different types of tests. We're not going to...
If Wikipedia sponsored us, that'd be great.
Yeah.
I don't think they sponsor anyone. They want to be...
I donate to Wikipedia every year to keep them going. I do give back. All right, so, let's talk about why testing is important, right? This is going to sound really obvious, but...
Real quick before we move on, IDE is Integrated Development Environment, to answer that question in the chat.
Yes.
So it is, think more than just taking your text editor, so Notepad, adding a whole bunch of automation and buttons and things on top of it to make it do more for you.
Usually they'll compile the code for you.
They'll compile the code, they'll autocomplete imports, they'll tell you common bugs, the styling and things like that. So it's everything.
Code complete sometimes. Just auto-complete it. All right. So let's get back to testing. Why is it important, right? It sounds obvious, but wouldn't we rather find our own bugs first?
Your IDE will run your tests for you too.
There you go. If you have any.
You have to have them first. Yes.
And so there's a lot of studies, management, they love to go out and collect metrics. There's all kinds of studies that show the sooner we find a defect, the quicker it is to fix and the less expensive it is to fix. And so, from a realistic standpoint, think about it, right? If I find it while I'm building the software, I fix it, it's pretty easy. If my test team finds it before we deploy to production, they're going to have to kick it back to development like we did in revision control last week, like that little tie together. That's fairly easy, depending on your process and how big your organization is. But now let's say it gets out to production, right? Now fixing a bug, let's say the users identify it, they engage. Now you're dealing with customer service, who then has to try to translate and reproduce it. And usually that reproducing process involves communication, tying back to one of our other modules. And usually we all know that communication is a big breakdown. And so it takes probably weeks to figure out what the problem is. And then it takes more time to go develop it, test it. And then, now we've got to push it out to production. So we've got to do a production deploy. So you see how this starts to grow in magnitude as it gets out there. So the sooner we find it, the easier it is to generally fix, right? And, God forbid, if your software is mission critical, I think, is it the Boeing 777 that had all the software issues? And it actually, they lost airplanes over that. And so, there could be broader impacts. If your software is mission critical, let's say, you're launching people into space, or you're, doing other mission critical tasks, it could be very important. So we want to make sure it's tested. Think about yourself being, on board one of those planes, or on some mission critical application that depends on it. So testing is important, and we want to make sure we're following those. So we've broken out like the different types of tests that we find are popular. Unit testing is our favorite from a developer standpoint, because that is just dependent on ourselves. That's when we write our own code. Then we write unit tests to test our own code at the smallest pieces. Usually we want to test very small blocks of code. And I'll let you know a secret. People always come up to me and tell me that their code is hard to test. Okay. I don't disagree with that statement, but what I hear when they tell me that is they've written poor code. Poorly written code is hard to test, right? If you have no inputs and no outputs, there's nothing to test. Now, the solution to that, and I always have this conversation with people, is break down your code into more modules, more functions, more procedures, more classes. Have those well-defined. If you can't write a quick 1 to 2 sentence description of what the current module or function is trying to perform with inputs and outputs, if you start writing a novel, then you probably need to break it down and break that novel down. Take 2 sentences and try to break it down into pieces. And then it's easier to test too, because when you have a small little bit of function, now you have a small little narrow bit of testing to do, right? When you have this giant paragraph, there's all these if, then, else, buts, and tests in there, and your tests grow actually exponentially. It doesn't grow linearly, right? And so that's what I love to have that discussion about unit testing. If anybody struggle with unit testing, please reach out. We would love to help talk through that. But unit testing is just the start. Now it gets really interesting. You can be a great unit tester, and this is where, Julio and I love to talk about. Julio and I can go write some great code, but when we get together and we do integration testing, which we're testing the code together, we have not typically communicated properly. And so both of our individual units are working properly as designed, but we didn't design them to collaborate properly. We didn't talk through the details of the collaboration. So integration testing often runs into problems. So the earlier you can start doing your integration testing and forcing that communication to happen, the better it's going to be when you start doing the integration testing. If you wait till the end and try to do integration testing of 100 different modules, it's going to be a struggle. So start trying to, think of building Legos. Start building them as early as possible. Start the integration as early as possible. Okay.
Typically, the integration testing we'll do as part of the development lifecycle. We'll have a developer go and write their unit tests, and then also write the integration test at the same time. So that way, when they have a reviewer looking at it, they can see the interaction of these things. And sometimes the integration testing is broader, and you'll have a separate set of things to go and do for it. The other thing to note as we go through these next couple ones too, in unit and integration specifically, is there's overlap. There's not a clear defined, this is unit, this is integration. I mean, you can argue a bunch of different ways that a test is both a unit or an integration test. The key thing is having tests. I was
going to say, I find myself arguing that we just don't have them.
Yeah.
I've never had an argument about identifying what it is. It's just, where is it?
Yeah. I'd rather have tests that are useful and provide confidence in the code that we're covering the different conditions that we want to.
Well, that's where I hate code coverage, right? Is I see too many. I personally can write some pretty crappy tests, have 100% code coverage, but not actually do good testing. And so we have to be careful about code coverage. Make sure we're doing good testing. We're going to talk through an example in a minute about that too.
Okay, perfect.
Yeah. So integration testing is just, hey, let's start testing things and putting it together as early as possible, right? And as Julio said, some of that might include unit tests, and so, but then we get up to system testing, and this is really the end-to-end testing, right? And I feel remiss if I don't say you should have some sort of test environment, I don't know what you call it, but it's not production, right? Testing in production is not the way we should go. You want to have a separate environment where you can test, model things, make it as close to production as possible, get realistic data in there. But don't test in production, please. Like I can't tell you enough how much I see that.
I still to this day see developers who just make changes in production. They develop new code and add it straight to production. They don't use another environment, any other environment.
Well, we were working with another company the other day, and we got an email about accessing the production environment. And so Julio graciously responded and said, well, we could give you a copy because I'm sure you want to test this in some other environment.
Yeah. And
they were like, nudge.
Yeah, and they were like, oh, I guess that would be a good idea too. They're like,
because we knew right away that they were going to test it in production. So it's just gently nudge people. And so system testing, you want to do end-to-end testing, not in production. And that way you can plan. And then it might shock you, but you should probably plan your deployment and test your deployment. So blow away the environment or load your production onto that test environment and then try your deployment. And here's a novel idea. If it fails, do it again until you do it without failing. Okay.
Yeah, that's one of the best things you can do. Like if you have a small project, your own personal project, like you're just testing something, you have your production server and that's it. You don't want to spend a lot of money. Just download the data, download a copy of your production data and all the assets that are associated with it, and just run it locally on your own machine against your code and just see that it works. That's a really great way to go and just make sure that, hey, a new release, especially if you have to make changes to your database or some sort of core structure, having that testing process beforehand is essential.
Yeah. Now, I will advocate that if you're going to do it in a production environment where your job depends on it, I would love to see that testing environment, a new environment, not your current machine, because there's too many times we forget to check in a file or do something that's a little different locally.
Well, that too.
And we want to be able to test it. But
there's also security considerations and compliance. You can't do that. I'm not going to say you should do that for everything. I mean, pulling down.
Just testing it. Like that's a start, right?
Yeah, just testing it is a start. But if you have certain compliances, like you have to deal with credit card data or health data, well, that starts to get a little bit more complicated and out
don't
of the scope.
That.
Yes, please don't download that.
But yeah, I mean, just test it, right? And then, as you do more and more deployments, you'll learn the ins and outs of failed deployments, and they can really hurt. So test your deployment as well. So we talk a little bit next about performance testing, load testing, and security testing, right? I'm a little passionate about these in terms of they frustrate me. Make sure you do your unit integration system testing first. If you don't have performance requirements, then don't do performance testing unless performance is a problem. I've seen too many developers, worry about optimizing code that doesn't need to be optimized. If you want to do that, go out in the parking lot, take a lighter, take $100 bill, and just burn it, right? We're essentially wasting time and energy.
I actually, an interesting thing, I had to write a serverless application this week with AWS Lambda. That is a case where, hey, you have to optimize everything you do because you pay for how much CPU, how much time, and how much memory it uses. So optimization is important. You get that savings by it being cheap if you optimize it. But if you're building a Java application that runs on a server that you're just paying for every month and it's $20 a month and you just get to use all the memory there, don't go optimizing it until you start having a problem or start identifying that, hey, I'm using more and more memory. Maybe I should figure out why. And you don't need to make something go from 200 microseconds to 200 milliseconds to 100 milliseconds.
1 nanosecond.
Yeah. It doesn't help anything.
So I will say one of the most common problems I see in the software development environment when we do testing is, Julio mentioned testing on his laptop or testing on his computer, whatever it is. He's got some crazy fancy desktop, but we'll ignore that for the moment. One of the biggest problems I see from a developer standpoint is we don't load enough data, right? Is we'll create a blank database of some sorts, or we'll load 100 records in the database. And then when we go to production after about a month, we get 1 million records and everything starts to fall apart because we didn't index the database properly or we didn't handle the load right. So make sure you put the proper amount of data and you're handling and testing with, probably I would usually try to do 110% of what you would expect in your current production environment. So you're always leaning forward and ahead of that. That's one of the most common performance and load kind of testing that I see missed. Now, again, get ahead of that, but don't be 10 times the load because you want to see where it's at. As a manager, I get really frustrated when my team spends weeks and weeks working on things that just don't matter, and then there's all these problems left unsolved. So I see a lot of people working on performance testing where they don't need to. And then security testing, I'll say this from Julio's very passionate about security, but I think it's one of the things that we never do, right? And we should do if we have security requirements. So if you have security requirements, make sure you are testing security, because those are one of the things that if somebody else tests it and finds out that there's a hole in it, you'll usually look like a big idiot. And the last thing you want your users doing is
that's the
finding
best case
out
that you look like a big idiot.
Yeah,
I mean, there's far worse.
You
things
end up
that
on
can
the
happen.
news, and that could be even worse.
Yes, yeah. There's security testing is one thing that, hey, if you put authentication in place, maybe you should check that somebody can't step around it. And
you don't get a mulligan on those.
Yeah, no, you don't.
So anyway, so be cognizant. If you don't have security requirements, then you don't need security testing. But if you have security requirements, if you have any PII, HIPAA, or any of those, make sure you're doing the reasonable checks to comply with those. We actually use a lot of tools to do some of those scans and stuff for us to make sure that we're compliant, because a second set of eyes always helps. And so when you're testing, that is another point, right? You should be the first set of eyes. One of the things I like to do when I'm doing testing is I like to go to bed, sleep on it, right, and come in the next morning and then write my tests. Because when you're writing software, it's really hard to find defects because it's in your mind. And I don't know if you've ever done this, but I've written tons of emails that when somebody read them back to me, it wasn't what I thought it was, because I'm reading it, looking at it, and in my mind, I'm scrolling it through.
I do that all of the time, where you're thinking one thing, but you type something completely different, or what you're trying to say just doesn't come through. It's...
And so after a good night's sleep, you're kind of fresh. Unlike me this morning, I walked in this morning and Julio was like, "Oh man, you're struggling."
And Brian looks like he's hurting, staying up too late.
Yeah, and my wife has me on this new running regimen, which she's probably trying to kill me or something. But after a fresh night's sleep, you can look at your code. And I've done this before. I'll come in, but I wrote that. That's pretty poor. And so then you can actually test it better. And then, once you get your test done, I would advocate always having a test team or a different set of eyes, code review, have someone help you with the test, because they're going to always see things that you don't see. And so that we collectively don't get better, as you probably get tired of me saying this, without collaborating with other people. Julio constantly pushes me and makes me a better person, and vice versa. So you have to have that collaboration and that feedback loop to grow. All right, so should we talk a little bit more in detail about writing a good unit test? I feel like,
we don't need to write good unit tests.
Prescriptive if we didn't talk about like the hows of it.
It's easy to say write tests, but what
is
write
a good test, right?
Yes.
Good test, right? A good test. So I think we have to be more prescriptive about that. And so we like to use the absolute value function, and I know I can see it getting ready to be written in the chat. There is a math function, so you don't have to actually write this, but this is the easy one to talk about an example, so that we can all do this in the morning. And so let's talk about writing the absolute value test, and more importantly, let's talk about testing it and how we would test it, right? And so, let's look at the input as an integer, not a floating point number. We will be here till the sun comes up talking about edge cases. And so what are the tests that we have to do to write for this? The minimal set of tests. Okay, has anybody ever thought of that? I'm going to pull up my chat window here. Hold on, bear with me.
And just as a reminder, the absolute value is, if somebody needs a little bit of jogging, it's been a little bit since you've had math, it should take in a number, and any number, and for our argument here, we're using an integer value, so 1, 5, 20, or a negative number, and tell you what the absolute value, what the distance from 0 is. The number 1 and the number -1 both should return 1.
Oh yeah. Hold on, I just screwed that one up.
So if we're using an integer,
There we go.
you trying to get the chat up there, Brian?
Yeah, I was trying.
Do you have your
horribly.
laptop muted so it doesn't blare out audio?
No, I don't. And I wasn't trying.
So if you guys could go
All
ahead
right,
and, if you haven't already, put in some values you think that we should test.
I have too many windows open. I thought I closed them. There we go. All right. Apparently, I have 400 Chrome things open here. Sorry, guys.
You're wondering why your laptop's crawling.
Yeah, Julio's always yelling at me. I
always-
just keep opening new tabs.
Yeah, Brian asked me. He's like, "Man, my laptop's really slow," and he has a top of the end laptop because I know he's a bad user. He goes and he
Yeah, Julio bought it, so he knows the specs.
yeah, it's good, and plenty of other people have the same laptop and they have no problems with it. I never hear complaints. It works perfectly fine. But Brian always has problems. I literally come over one day and he says, "Can you help me and look at my laptop? Why is it running so slow?" It's like, "Well, Brian, you have like 35 Chrome tabs open, and then you have like this other application running." I was like, "Maybe you should close a couple."
There's
of
my
those."
downloads folder. I couldn't download anything anymore.
Yeah, and I was like, "Let's just delete that
And like
let's just
10,000 files.
Close
in it.
Chrome."
Apparently, there's a limit.
Yeah. So, all right. So some of the some answers are coming in here for what we should test. So Oliver said -1, 0, and 1. What are your thoughts on those, Brian?
Nice. That's a good start. Why not -3?
Why not -10?
Yeah.
What about -30?
Yeah.
Well,
3 is my favorite number. We'll use 3.
I will say as a developer, I don't like. I like writing tests. I like having the confidence of having tests that they'll work correctly and that my code does what I expect it to. But I don't want to write like tests forever. So you definitely. I don't think we need to go and put -10 or 10 if we have 3 and -3. I think 0 is perfect. It's just a boundary number.
So that's the key, right? Essentially, we really are looking for boundaries.
So
Right,
different types of boundaries.
Yeah. So for unit testing, you're trying to identify all
a
the
normal
boundaries.
case and then boundaries.
Yeah. Well, and even the normal case are considered boundaries, right? So 0 in itself, that's a great one because it is a special case, especially in math. 0 is always considered a boundary condition. So ultimately, for testing, we're looking for the boundaries. Where do things change?
Yep. So Alexander brought up another one here. Perhaps testing integer overflow values in case incorrect input is passed. That's certainly if you're using a language where that could happen. Absolutely. So
let's adjust it for him. I think he's on to a good point. So min and max int.
Yep.
Right. So those are the ultimate, left and right boundaries. We'll say min and max boundaries. So those are edge cases in itself, right? So min and max int, those are 2 edge cases. So that's perfect.
Yep.
Right. And then as we move in from, whatever the 2 to the x power is, as we move in, right, we're coming closer and closer to the plus and minus 1, right? And plus and minus 1 are other boundary conditions because weird things happen at 1 with math. And so those are your other boundary conditions.
Yep.
And then as you move inside of 1, what happens? 0. So those are your 5 boundary conditions, right? And so the point is so 0, 1 and -1, min and max int are the boundaries. And so when you're testing, you want to just look for those boundaries where things transition. You want to test the transition points because nothing will change in the deep sea of the non-transition places.
You don't need to test 1 million and -1 million.
Now I will say there are some instances. I mean, if we change this from an integer input to a floating point integer, as you approach 1, as you approach -1, you start getting the number of test conditions rise exponentially.
Yep.
So there are going to be instances where it's just there's almost an infinite amount of tests to do, and so you have to figure out. I like to say write the minimal amount of tests where you feel like you're productive, because if you feel like you're just writing tests to write them, again, let's take $100 bill, go out to the parking lot, and we can burn it. And once you're into that mindset, you're not adding value, right? And I will say, management can ruin us. I had a manager come out to me and they're going to start taking metrics on lines of code and number of tests. Well, just tell me the amount of tests I need. I can produce them, trust me, right? And tell me the amount of lines of code I need. I can write lines of code. I didn't say they'll do anything productive, but if you're going to judge me on metrics, I can produce metrics to look like anything you want. And so we have to be careful about metrics and how we put them in front of teams. So I'm very cautious about metrics and really more about, hey, let's be productive. Let's add value. As soon as you feel like you're not adding value, just stop writing tests, right? You'll know it, right? You should know it right away.
And as a junior engineer, you should definitely talk to others on your team if you're not sure what these boundary conditions are. If you're writing something that does
zero tests.
Yeah. You definitely don't. The zero test is not the way you want to go. You would definitely want to have some sort of tests, but talk to your team to figure out what are these boundary conditions. What should you consider, especially if you're new to an application that has a lot of history on it. There could be use cases. It's never going to be as simple. I mean, unless you're writing an absolute value function, which you probably shouldn't be doing, but it's not going to be 0, -1 to 1 in min and max int. It's going to be some weird edge case with the data coming in with this different value in it versus this other value that you have to test for.
Well, and that's where, without getting off my horse too much here, is that's where we developers have to understand the business. And we have to start to understand what they're doing. And it helps us be better developers in terms of writing the code, understanding the outcomes, and also testing. And so we have to spend time to learn and understand that. And the other thing is, participate in code reviews, because not only are you giving feedback, but you'd be amazed how much you learn by seeing what other people are doing. You gain context, you gain awareness. I encourage the most junior members of our team to do code reviews because they often surprise me with phenomenal feedback. They catch things that nobody else catches because they're looking at things that differently. And so, but at the same time, they're gaining insight into broader things that the team are doing. So those are very unique ways to leverage good practices to perform ancillary, unrelated tasks that will benefit the entire team. So as we move down, we have mocks and stubs.
Yeah, so these are mocks and stubs are a good way to, hey, I'm writing a test and I want to write something that I have some complicated conversion logic that changes this one object to another object and does some computation in it before it saves it to the database. Well, how do I just want to test this logic here. I don't really want to test my saving to the database because I know that works, or you're using some other library that you at least think works. You're going to reliably trust it for the sake of your unit test. And so the concept of stubs and mocks are ways to implement that functionality or hide that functionality from your test so that you can isolate your test more effectively. I'll say that there's overlap again with testing. There's a lot of overlapping concepts between things. Stubs are if you were to go and have an interface and you just write a stub that just doesn't do anything and you just have that class there. A mock is similar to that, but is more typically a framework that allows you to dynamically add functionality to an interface or to an existing class that you don't have an interface for. The long and the short, both of them allow you to go and hide the functionality, add really limited functionality behind like a saving to the database. You don't actually want to stand up a database or have sample data or things like that. You just want to test this conversion logic. You can write a mock that says, hey, I expect this value to come in and I'm just going to return this value back. And then the key thing with stubs and mocks are that they shouldn't be your sole set of tests. If everything is just mocked and stubbed out, you're not going to get the value out of your test.
I've seen these mocks that are like 15 pages of setup. That's too much.
Yeah, you don't need really a massive amount of
far.
mocks. I'll say typically mocks and stubs are good for really complicated areas where, you want to isolate functionality. But nowadays with how testing frameworks have expanded and are more readily available and usable in the open source, it's easy for you to go in and stand up a lot of things in your test to make your tests more usable. A really great example of this is the concept of using test containers. This is something we do in our applications where it stands up a Docker container of our Mongo database or our MySQL database or whatever else the services we need. So that way in our tests, we don't have to mock out the calls to the database. We can write a test right to it with no extra real headache at
And
all.
I assume you're loading those with a preset of data.
Yep.
So,
yeah, you go and you just load it with the data that you know. So like there's again.
and as you find new conditions, you could add new data.
Exactly.
One of the other random things that I kind of, probably I'm out on my own island here, but I loved mocking to test exception handling. Because a lot of times we found there was oddities in how we handled certain exceptions. So I love to write some of the exception handling testing just to make sure that, honestly, the biggest thing is to make sure we were properly capturing failures so that we could properly identify.
Well, handling the propagation of them,
Yep.
making sure that your code does what it wants to, or what you need it to do. One of the things, I guess, a lesson learned that I tried to do at one point was testing various log messages that got logged during exception handling. I wouldn't recommend that. That gets a little bit too over.
What, you get tired of the copy paste log messages?
Yeah. If you have to copy and paste the message every time, it's not really that great of a test.
Well, what I found is a lot of people copy and paste code, and then the logs come along for free, and then the log message has nothing to do with the code anymore.
Yeah.
And so then you're like, and then you find the original log message, and you think the problem's there, and you, after spending a week of trying to solve a non-existent problem in that area, you'll quickly start looking for those. But anyway, I digress. All right, so we have a little note in here about test-driven development. I'm not really a big advocate personally about test-driven development. I'm really more of an advocate that we do testing, right? And I think there's cases to be made that test-driven development would work in those cases, and that's fine. It's like anything. Use and make those decisions as you arrive to them. I think as long as you're performing good testing, whether you do it initially or after, it doesn't matter to me. I'm just going to be thankful it's happening.
I think in the case of any of these, even with like things that we do follow, like Agile, test-driven development is something that you can take bits and pieces from and apply to what it is you're doing.
Well, we don't even follow Agile to the letter of the law.
Exactly. Again, you have
to.
You have to take what works for your team, for your customers, for your problem, and combine these things together to come up with a solution. There, you can't just prescribe like a one-size-fits-all for everything. So, test-driven development, I say, would be it's good if your team's all senior developers who know the business really well. I think it's better to think of it as more business-driven testing development, in that you should write tests that solve your business use cases. And if you need to go and write the code first to understand what it's even going to do, because you don't understand what it needs to do first, how are you going to write tests for it at the end? Now, if you know that, hey, I want to go and build an API that has these endpoints and does these things, and then maybe writing a test beforehand might be beneficial just to make your life easier.
Well, and the key here too is you're doing the things that work for you, but don't eliminate the things you don't like, right? It isn't about a la carte choosing things you do and don't like, because ultimately you have to figure out what actually gets the best results, and that's the concept of retrospection. So don't cut out the things you don't like, because those might be the things that are the most productive. Oftentimes, the things we dislike are the things that are helping us the most. So figure out what truly does and doesn't work and why they don't work, and then eliminate them for those reasons. I find too many people eliminate things they don't like, which is unit testing. And so we want to keep the things that are and aren't working, and why. Ask why, really. Like, get down in and figure out the whys, and eliminate the things that aren't working and figure out why they're not working and improve upon them, because you may need them, like unit tests. I can write ineffective unit tests. Well, we still need them. So why aren't they working? Well, they're ineffective. So let's write effective unit tests, rather than just say, well, since they're not working, we'll stop doing it, right? If you don't like food, you're going to stop eating. I didn't think so, right? All right.
So let us know in the comments if you have any questions about testing. There's some things we didn't even talk about in here. Test automation.
We could talk for days about testing.
Yeah.
The goal is to get you interested in it,
and
not scare you away.
Another great area that we didn't talk about that maybe, Brian, if you want to add a note for it, is end-to-end testing or user testing. So using something like Selenium or Cypress if you're building a web application and even I think there's tools for this for desktop applications, but having a way to automate functions that if you're building your own little web app in free time and you want the best bang for the buck tests, I would say that would be your Selenium or end-to-end tests, where you're going in and clicking the login button, clicking over to the tab, doing X, Y, and Z in the application, is going to provide the most value especially for your side projects and things like that, to make sure that things don't break, or even a school project. If you're building a web app, I would definitely recommend nowadays. Cypress is really great for that. Selenium has a lot of value and a lot more flexibility, but Cypress is definitely expanding out. So those are definitely an area I would check out.
Yeah, nothing's more embarrassing than having either broken links or buttons that don't work in your application, because
there's just some sort of regression.
Simply has to push the button, right?
Yep.
It's a really hard argument with management that like nobody tested the button. Like, just press the button, not like this, press these things, stand on your head and do all 10 activities. Like, those are different cases. So make sure you have the bare minimum, because it's embarrassing when you don't. All right. If there's no questions, we can move on to the 5-year roadmap for software developers.
Yeah, I'd say let's go for it.
I lost my chat window here. All right, so let's talk about why. So why do we talk about the 5-year roadmap? Is what we want you guys to be doing is, as you successfully enter the workforce, we want you to be looking ahead. We want you to start looking at where to go next. I've done several college interviews, and I always love these. I always get a smile when the person I'm meeting with, pick your favorite language. We'll do Java, and they'll come up, and then we'll interview them, and they'll say, I'm an expert at Java, right? I know the API, ask me any question. So I have a few questions to humble people on those. But more importantly, it's really less about Java and how do we make well-rounded software developers, and how do we start getting you guys to look at the real tools and techniques that you need to refine to be better overall developers, and throw language away, right? Most of the tools and concepts we're going to talk about apply outside of or to all languages or to concepts, right? And so we really want to get you thinking of these concepts, get you looking at pushing into these realms, because you don't get good at them by just trying them once. A lot of these concepts, it took me years of trying and playing with them and refinement to get better at it. So we've put these out there. So the first topic that we try to get people to understand is design patterns. And so there's a famous book that we all refer to as the Gang of Four. I didn't bring it in here. I should maybe go grab it.
Yeah, we'll get it next time. We'll put the notes.
Oh, hold on. It's amazing. I forgot we can share screens every once in a while. I wonder if Gang of Four will even work if I search it. No, that didn't work. All right.
It's you just go to Wikipedia, Brian. Just go to Google.
I think I have the link in here. Hold on. Oh, I got it. There it is on Amazon. Right. So feel free to share my screen if you want.
Hold on. I'd pull the Wikipedia page up.
Right, hold on. I think I have it right here.
Your addresses in there.
There's a link. Oh, no. Hold on.
Go to Google. No, Google. Watching Brian type is painful sometimes.
The lesson learned is he should do it.
There's a book. It has it's the.
There it is. There we go.
All right. Here, now I'm sharing a screen. So this book is the Bible of design patterns.
Yes.
It was the original book. It's
I don't remember the year it was written, but it was. It
says right there, 1994.
All the examples are actually, I think, it's C++.
Yeah. And most books nowadays are just derived from this. It's the same concepts or combinations of these core
all
patterns.
they do is combine them in different combinations and call it a new book and sell it to you, so don't buy it.
Yeah, this is the core patterns here. It's a great book from the standpoint of having it as a reference and being able to open it up when you have a problem. If you want to put yourself to sleep, if you have insomnia, it's a great way to help with that. It's a very dry book, but on the front and back covers, there's essentially a cheat sheet of the different patterns that you can go.
Yeah, it's worth reading those 2 pages. That's what I always tell people. Go read the 2 pages that there's each of the patterns are in there, and there's the 1 or 2 sentence description of them. Read that. And then when you want to use them, then go reference the larger pattern and read the details about the pattern.
Yeah.
But the key to what this book does for you is it's talking about design patterns that when, like, let's say the factory pattern. If I talk to Julio and I say, hey, we should use a factory pattern here, now all of a sudden that's the simple conversation we need to understand a complex task that nowhere in there is language, right? You know, he could be working in PHP, C#, Java, Python, but now we're talking broader than that. And now we immediately have context for thousands of lines of code without having to ever do anything, right? So we've raised our discussion up a level, okay? And we've had that discussion. The other thing about this book I'll say is it's a recognizable book, right? If you have it on your bookshelf at work, people are like, oh, wow, you read that book, or you're using design patterns. That's awesome. And it's a great interview question, right? I mean, if I ask if you have that book, right? Oh, just describe the cover for me. If you can't tell me it's got a blue stripe down the front cover and it's white, then you don't have the book. It's pretty easy to know that. And it's one of those books that gets respect, but more importantly, it creates a commonality of language and it raises you up. And so you can start implementing these patterns, or more importantly, there's generally tons of libraries, you know, with Java, the Spring Framework provides a lot of these patterns in different ways. So you can go look them up and just use them. People have written them, you know, so you can have immediate access to these patterns. All right, I'm going to switch my screen here.
Yeah, you're good.
Am I? Okay. I can't tell anymore. All right, so design patterns are important. Allows us to start doing that way. I will say the only, so you don't have to buy another book, the only pattern that I felt was missing, if you want to share my screen again, I'm sorry, from the Gang of Four book is the marker interface pattern. So the marker interface pattern was kind of invented after that book was written, and it's more of a newer language thing because C had multiple levels of inheritance, so they didn't really have the marker interface pattern. That's the only pattern that I love and I find very useful that's not in the book. So it saves you from having to buy another book. Every other pattern is in that book. You buy the one book, copy this Wikipedia link, and you're set for life in terms of design patterns. And I tell you this because I bought tons of design patterns books. I read them trying to learn new patterns, and I just got more and more frustrated that they all referred back to one of these patterns of the Gang of Four in some combination thereof, and it became very boring, and I started burning these other books because that was the only value I found in them, was heating my house. All right.
Trying to think, Brian, is there any, I think the sort of from a 5-year roadmap too, the next part that's really important is learning to build highly configurable software.
We're missing Dustin this morning.
Yeah.
Dustin, you should be here.
This is, he's probably watching, is highly configurable software. So Dustin wrote several articles about this. Brian will have the links for that in the notes that go out. But the idea here is that you don't hard code things. It's one of the really core concepts there. It's really easy to go in and just write your code, and just think about, hey, I just need to go and get this to production. Well, what if you want a testing environment? What if you want to deploy another instance of your application? Having these values that you can switch in and out dynamically is really, really essential to growing your skills and growing your application. A really good example of this is if you're familiar with .NET development, they have the web config file, and you can do transforms on it. So being able to set up your properties in this file and transform it when you build it for different environments is a really good implementation of this concept of highly configurable software. So without stealing the thunder of the articles themselves.
There's 10 of them.
Yes, there's 10 of them.
They're amazing.
They're all listed out in the notes here, so you can read those. They're really good for, again, understanding where you need to go as you build software, not just saying, hey, I'm just going to build this one instance of something. I should be able to build it so that I can swap things out and not be pigeonholed into one way of doing things.
Yeah, and highly configurable software is important because it gets into one of the other passionate things is writing reusable software.
Yep.
The more configurable your software is, the more reusable it becomes. And honestly, the more modular and reusable your software becomes, it becomes easier to test. It's actually a lot less lines of code, right? It's more configuration. And so those are things that we want to see you doing as you mature as a software developer, right? Is reusable software, right? I'm very passionate about that. And I really started early in my career trying to figure that out. And because it adds value. But it's a lot harder than you think, because reusable software isn't, I'm copying and pasting the code over here. Copy and paste code reuse is not reuse. But truly good reusable software is something that Julio wants to use. Right? All of a sudden, you've got other people coming to you wanting to use your software. And that takes a lot of maturity in your software development skills. Everybody's going to hate me for this one, but really awesome software is just well documented. Because if you start to think about what people want, they don't want to look at your code. They just want to download it and for it to work. And for it to appear that way, then it has to be simple and easy to understand, and more importantly, well documented so they can understand it. And so reusable software is one of those things that we want you to look at in your 5-year roadmap. And then that will be, leveraging highly configurable software. And so a lot of the articles that Dustin wrote start to walk you through highly configurable software, key configuration points, and also, doing the inverses. Don't have too many configuration points, right? Because you can overwhelm yourself too. And so it's getting that right balance. And so those articles are doing that. So I would implore you to read those articles. I've personally helped to review them, so I'm well invested in them. So I can say that from a bias standpoint. And, as you do that, you're reducing the amount of code, so maintenance goes down. And so what do us developers want to do? Write code. What do we not want to do? Spend time maintaining code. Doesn't mean that, operations is important, but the less time we're maintaining, the more time we're doing new code.
Yep. All right. So again, all the links will be in the notes when we send them out. The automated process, aka Brian, verifying it. Brian is the automation in this case. We'll go and send those out. So moving on to the next section here, cybersecurity for system administrators. So this is a module that's near and dear to my heart, and one that I think is essential for not just system administrators, not just DevOps engineers, but for software developers as well, especially if you're on a small team or you're building your own personal project. Understanding good cybersecurity practices is just a good set of skills to have.
Well, and early on in the Linux module, we talked about why it's important is most of the time on teams, our software developers are our system admins. Yep. And we're heading more and more in that direction with the Agile and Docker and all these things.
There's a number of things that are pushing it to that direction, yes. That understanding some of these fundamentals will help you get a leg up on the others around you and
differentiate.
Yep, and differentiate. Yes, thank you, Brian. So getting into it, one of the core things is the local user management. So when you start a new server, when you start a new project, most cases you'll go and set up a server. Nowadays, you might not. You might go and use something like AWS Beanstalk or Kubernetes or serverless or something like that. But maybe you do create a web server. You go and you set up a Linux server on pick your favorite provider. And when you go in there, you go and you have the default users that's created for you. You log in, you do all your setup and whatnot, and that's all fine and dandy. But now you would need to go and add someone else to the server. And so the first thing that you go and you do is, and we have all the commands in here so you can follow along with it when you get the notes, is you go and you do a user add. You add your friend Tom. And so Tom's going to be helping you with the back end of your application. So you create Tom a user, you set his password, and you then create a group on your server because you have files in your var.dub HTML. Let's say you're making a PHP application. And so you set it up so that Tom and you are in the same group. You may give that group access to write to the directory where all your code is. Nothing too crazy there. So you're going and you're doing that, and now your application starts to scale, and you're like, oh wow, I need to go and have another server on here. So you go and you create a new server because you need a load balancer. You put a load balancer in front, and you you then log into the new server. You go and say, okay, well, Tom and I both need access. We both need this group. We'll go and set that up. And that works fine for a while. Things keep growing. You add more code, and your application scales. And you need to add a third server and a fourth server. And then your team grows, and you have Sally, and you have Joe, and you have Susie, and all these people that you're adding all their accounts. And then one day, someone on your team decides to go, and they're going to go work for a different company. They move on. So now you need to log into every one of these servers and remove their access. You want to make sure that they can't log into your 25 servers with your application running, because you can't. It's too risky to have that. So as you start to scale that, one of the first things that I like to do nowadays with any new server that we have is setting up some sort of central authentication. And there's a number of different ways to go and do this. I'll say one of the more popular ways is using LDAP. So LDAP is the Lightweight Directory Access Protocol, and is a really great way when you're managing a bunch of servers or a bunch of desktops to go and centralize the authentication. LDAP's an open protocol in that most applications that have some sort of, I'll say, enterprise-like capabilities can authenticate to an LDAP server. You can go and Active Directory is built on top of LDAP. It has the capability to perform LDAP as well as some other authentication protocols. Linux works really well with it. It's a great way to go and start saying, hey, instead of having all these 25 servers, each with their own users and groups in here, I'm just going to configure these servers to reach out to my LDAP server for authentication and offload all of that. And so this is a great way to start organizing your groups and your users, and when you have more than one or two servers or desktops, centralizing all these things. And so, and I'm actually going to add a note in here because LDAP works really well for system to system, where you have a desktop with, you configure it as the root user to go and authenticate. Nowadays, one of the more popular web-based authentication, because as you build out an application and you start getting more users on it, or you have microservices or any of these more complicated approaches, you need some way to authenticate your users against your different web applications. So another sort of centralized protocol for authentication would be OAuth or OpenID. There's a whole bunch of others out there, SAML, that all perform the same concept of centralizing your authentication into a single system that allows you as an administrator to go and have one place to go and say, hey, give this person access to this application or remove their access. Very simple, very straightforward. Or you as a user to go and say, hey, I want to revoke my access from this application. This is very common where you do like the sign in with Google, sign in with Facebook. You can give your users that functionality as well. So as a system admin, as you grow your team and your number of users and the number of servers, getting some sort of central authentication mechanism that works for you is definitely a key thing to implement. One of the more complicated ones that we see, I'll say more on the government side of the world, is with certificates and certificate authorities for authentication. And so I know we've talked somewhat about certificates before. The idea is just instead of using a username or password, you use a certificate authority. But this is the same concept of centralizing authentication into a single ecosystem that everything can sort of hub and spoke to. You can have your central system that does all this authentication, issues the credentials, and your users and your devices will check against that system and perform the login and log out functionality.
And that reduces a lot of the whole sticky note password problems, right?
Yes. Yeah. You don't have to have like 35 different passwords for 35 different systems. You have just one password for the entire ecosystem. It's definitely great for preventing password reuse.
And lack of frustrating users.
Yes. Yes. Yeah, especially when you start talking about user-facing applications, centralized authentication is really critical to that. It provides a more seamless experience.
If you're running like a help desk for password resets, I mean, that could be a full-time job if you don't have it centralized and everybody has 35 different logins every day. I have no idea why we have 4,000 calls a day to reset passwords.
Yeah. So that's kind of the first thing is like as you're getting into setting up a system and worrying about cybersecurity. The reason you centralize authentication is for again simplifying user access, which isn't really cybersecurity, but it is in a tangential way in that you don't have more than one password to manage. So it's easier to have one more memorable password when you start talking about things like implementing multi-factor authentication. That's easier when you have a centralized system, and you don't have to implement in every system. It then also allows you to lock out accounts, and people who no longer should have access, you can remove that. So it's definitely a key thing to keep in mind. Moving on to other sort of core concepts that we really feel are important is just understanding the fundamentals of networking and networking security, in that understanding how your application talks to your database, and how your users connect to your application, and the difference between what runs on the client's browser, if it's like JavaScript versus on a server side, and understanding how this flows over different ports and over your networks, and how your traffic that you allow in and out are configured. And the primary way of controlling this sort of information is two mechanisms: either your firewalls or your intrusion systems, or a combination of both. So most people have heard of a firewall. You typically have one just built into your router at home, in that it allows you to open up ports or do port forwarding and some other routing functionality too, but allowing in or out data across specific ports. So when you go and you set up a server, and you're going and allowing your web application out, you don't want to just disable your firewall. You want to go and allow the specific ports through for your web server and things of that nature. Intrusion systems are like the next level of, hey, I'm allowing traffic over this port. Well, what's the data that's going across it? What's the application that's running on it? And intrusion systems are intrusion detection systems, or intrusion protection systems, or prevention systems. So IDS or IPSs are other systems that are software or hardware devices that allow you to sit on the network and look at all the traffic and understand and interpret, hey, this looks like something bad, or this looks like something good, based off of that intrusion system software. So these are more advanced systems. You'll typically see, as a developer, you'll see these in web application firewalls. There is another example of these, where you have a system that sits in front of your web server that checks for known good or bad traffic that's web related. So other things about networking that are important to understand. Again, we've talked briefly about certificates and how you can use them for authentication for signing users in. The other area is using them to encrypt the data between your users or your systems, between your application, your database, or between your microservices, is using SSL and encrypted communication across those to make sure that someone can't easily intercept that and see what the data is, especially if it's sensitive information or even non-sensitive information. There's nowadays, with the prevalence of things like Let's Encrypt and free certificates, there's no reason not to encrypt your data over your network to prevent tampering or man-in-the-middle attacks or things of that nature. So building on that, when you're administrating systems, it's not hard to do this anymore, but I like to bring it up, is when you connect into a remote server, you do it over some sort of remote shell or remote terminal service. And back in the day, the way that this was done was with a tool called Telnet. And so Telnet, it allows you to go and run commands remotely on a server. Very simple. You can, if you opened up a command prompt on a local on your laptop that was running Linux, it'd be the same thing as doing that, but just on a server somewhere else. And so one of the big problems with Telnet, and the reason it's no longer used, is because it was not encrypted. It would just connect and send the traffic just open and plain. So it's in the password, it's in whatever you're typing, whatever the server responded with, all in the clear. And so nowadays, the de facto tool to use for this functionality is SSH, or Secure Shell. And what this does is it sets up an encrypted channel between you and your server to go and send commands to and from and respond with the data from the server. So when you go and you set up a server in AWS or DigitalOcean or Linode or wherever your server is, they'll have instructions for how to connect with SSH. So that way you can run commands remotely but securely. So this is something that you typically don't have to think about anymore. But one of the areas that can sometimes be overlooked is file transfers. So one of the things that people don't necessarily always realize is FTP is also not encrypted by default. And so if you're using FTP to upload your files to and from your server, again, nowadays, I think, and again, I'm not going to speak for any of the providers out there because I don't use FTP all that often, but I'm assuming we'll set up something like SFTP, so SSH file transfer protocol, so it uses SSH to do your FTP, or it will use FTPS, which is just SSL encrypted, or SSL TLS encrypted FTP, to go and move your files to and from. So just keep an eye on that if you're using FTP, that you are using encrypted channel, so that way your files that you're transferring are not transferred in the clear. The tool that I use though personally is SCP, so secure copy. It's just another tool on top of SSH that allows you to copy files from your local server or from your local machine to your server and vice versa. And all those are, again, SFTP, FTPS, or SCP are all great ways to go and do remote transfers in an encrypted manner. So a couple other things to keep in mind that we feel are important to securing your application as you grow and as your number of servers you have, is keeping in mind the concept of a VPN. And this is one I like to talk about because there's so much marketing out there nowadays about VPNs that isn't inherently wrong, but it isn't not misleading.
Yeah. I was going to say misleading.
The idea of a VPN at its core is saying, hey, I need to secure my communication between a device, whether it be your laptop or a firewall in your network, and have it encrypted from point A to point B, just all of my traffic. So a VPN is taking the concept of doing HTTPS for just you connecting to a website, but saying, hey, I'm going to encrypt all of my traffic and have it go out at this other point. And so the type of VPN that nowadays most people are familiar with just from marketing and things like that are not even remote access VPNs, just client VPNs, where you're downloading some sort of client software, installing it on your computer, and it connects you to some server somewhere else. The famous marketing one that I always see is so you can go and watch Netflix videos or YouTube videos that are region locked. So you can go and connect to a VPN that's run by name your favorite VPN company, and what it does is it connects to their server. It encrypts all your communication from your laptop or your desktop and sends it to their server, and then from their server it gets streamed out. So their server might be in Japan or the UK or Africa or South America or wherever it might be. And your network is, or all your traffic is tunneled between you and there. And there's benefits from an advertiser tracking and privacy perspective that, hey, you don't want your ISP to sell your data, or you want to go and access region locked data. But one of the more misleading things that I see from them is that, hey, now you're securely connecting to the internet. And that's not inherently true. Now you're just changing where you're connecting to the internet from, in that your data is now going to their server, and from their server, it's streaming out to all the different sites that are out there. And so if you're connecting to an insecure site, you're still going to be something over HTTP versus HTTPS. Your traffic's only going to be encrypted from your desktop or laptop to their server. And then from that point, it will be unencrypted. So you have to keep that in mind. People also think it's going to keep them safe from the government, and they're going to not be able to hide and do things. And again, if the government wants to get a hold of that information, there's far easier ways for them to get that than getting in between your traffic. They'll go issue a subpoena or something. So we don't condone any of that at all. Don't do things that would cause a government to come after you, is the safe rule that we would like everyone to follow. But in respect to a VPN, if your concerns are with privacy from advertisers and things of that nature, a VPN can help with that, but it's not a tool by itself. Now, from an organizational perspective, VPNs have been around for a very long time and serve a multitude of purposes beyond just privacy and accessing region-locked data. One of the ones that you've probably used that you never even realized is a site-to-site VPN. So if you work for a company that has maybe more than one office or a data center that's remote, what typically will happen is your system administration team will go and set up a VPN within your firewall or your router or in some dedicated device in a networking closet, and set an equivalent device up over in wherever you're connecting to, such that if you're logged into your desktop at work and you need to access a server that's over on the other side of the country that your company has on another network there, and you just are able to connect to it, no problem when you're there at the office, but not anywhere else, it's more than likely that because they've set up a VPN that allows you to do, again, a VPN is a virtual private network. So it allows you to bridge and create a virtual network over the open internet between two either physically distant, or they don't have to be physically distant, but just two different networks. So these are transparent. You typically won't see these. You're not going to install any client software. It's just going to work from a user perspective. And that's why a lot of organizations use these for connecting to two branches or two campuses. If you go to a school, this will typically be something they'll do between campuses. They'll have it at their primary campus, they'll have their data center, and maybe they have a remote campus, and they'll just connect them all together with a site-to-site VPN. As long as you're on one of the networks there, you can connect to all the others. It makes it really easy from a user perspective. The type of VPN that you might want to set up for yourself, or that, again, your company might use, is also called a remote access VPN. And so this is a way where, again, you install a client software to go in and allow you to connect to a network, and the system administrator will set up some type of VPN server, something like OpenVPN or PFSense uses OpenVPN. There's a whole bunch of others out there nowadays. OpenVPN is the one that I'm familiar with. And what it does is it allows you to go and install a client on your laptop or your desktop and connect in and access the network there at your office. These are more similar to the type of VPNs that you see marketed to just the general public. But instead of changing the location where your IP is from a standpoint of accessing region-locked data, they might go and make it so that, hey, if you have a company laptop, you run the client VPN software, and it connects you into your network like you're sitting there at your office. So that changes your IP because now your traffic's being routed through your company's network. But now you can access your remote resources. You could access file shares or web applications or whatever it is that are behind your VPN or your firewall. So these serve a really great purpose of allowing employees and users to access resources that are behind some sort of firewall that you don't want to publicly expose. So, so that's VPNs in a nutshell. As a software developer, you may not use these too much, just given that you might use SSH tunneling or just have things running in like AWS. You can set up VPNs in AWS so that you can go and access resources you don't want to expose publicly. But otherwise, these are definitely useful tools that just are silently working in the background in most cases. So other key things that we like to talk about, just longer term things to think about as you get into cybersecurity for system administration, is the ability to automate things. Again, there's an underlying theme to everything we talk about, and that automation is key. And that having the more you can automate with your system administration, the better off you're going to be from a cybersecurity perspective, in that you will know what your systems are doing. You'll know how they're configured, because ideally the automation should be backed up in some sort of revision control like Git, where you can tag and version it. The prevalence of infrastructure as code, so automating AWS and the APIs they have to go and stand up servers or different services and deploy your code in your applications. You can go and automate all that, so that way you have a process to commit it, review it, and then deploy it out. And you can repeat that over and over. So if you want to go and test something again in a different environment, you can go and change those out. So automation starts to take that next level of system administration and starts to apply these core concepts of software development we talk about: highly configurable software, testing, revision control, and applies them to the security of your systems, or allows you to apply it to the security of your systems. So just going through here, and I think that's everything that I have for cybersecurity. I think one of the small parts I have in here that some people have questions about are in respect to security operations centers, so SOCs. This is something that you'll start to see if you're wanting to get into cybersecurity, that you're not quite sure what you want to do. A great way to get exposed on if you don't want to do development, is working in a SOC. And typically you'll work as like a security analyst or something like that, where, hey, you have all these different tools that are collecting information and logs and alerts and telling you when bad things are happening. Well, who's looking at that and understanding what that means and what to do with it? And those are the folks that work inside of a SOC. So typically these are 24/7, 365-day teams that work and monitor the systems, primarily in large companies, or they're as a service for smaller companies, where you can work as a security analyst to respond to these alerts and sort of get your feet wet, seeing what's out there. There are a number of other roles in SOCs typically, including incident responders, malware analysts, system administrators, and sometimes they'll work with the development teams to go and manage their applications or integrate them in with the monitoring tools. So definitely a great place to look if you're not quite sure what you want to do. The other place obviously would be working as a software developer and learning fundamentals of building applications and then applying security to those. So,
yeah, I'm just an advocate for getting any experience, right?
Yep.
The more experience you gather, the more you know what you do and don't like.
Yes, absolutely. So,
and honestly, the more experience you get, the more well-rounded you are too. So I would say no experience is a bad experience as long as you learn from it.
Exactly. Yes. So, all right, Brian, did you have anything else for today?
No, thanks for joining us, everyone. I think Pat would reiterate to share and like us on social media to help provide this out to anybody else.
The video, give us a subscribe if you can. We'll, over the next year, we're going to be putting out more and more content on this channel, not just these live streams here, but hopefully other informational and educational content to help you guys get into the workforce or continue growing as a developer and expanding your career.
And feel free to invite others as always. I mean, this is open and free to anybody, so have at it.
All right. Thank you.
Thanks, everyone. Be safe.
See you next weekend, I think is the next one. Yep.